So we just finished graphing rational functions, right, and reviewing them. Another major topic in pre-calculus is critical numbers, right, and really looking more towards inequalities. And so I have a problem here, right? So it states that x squared minus x minus 12 is greater than 0. And so we have this, and to determine the critical numbers and exactly where where the solutions lie for this specific problem, we have to factor this out, right? And so we factor this out, we get x minus 4 times x plus 3 is greater than 0. So we have this, and so we know our critical numbers, and these numbers are really just numbers that you get once you factor out your expression, right? And then you set each factor to 0, and then the values you get by setting each factor to 0 are your critical numbers. So your critical numbers in this case, right, are 4, and negative 3. And just because I set x plus 3 to 0, I got negative 3 as one critical number, x minus 4 to 0, I got 4 as a critical number. So these are the two critical numbers that I have here. Now what you do is you have your you're looking, so you first you want to obviously plot your critical numbers, right, on the number line here. So we have negative 3 here, possibly 4 somewhere here. And now all we're doing is we want to find one value that's greater than 4, one value that is in between negative 3 and 4, and then one value that is less than negative 3. And then plot those values into this equation to see exactly what value we end up with. So if we plot 5, because that's greater than 4, we see that 5 minus 4 is 1, 1 times 8 is 8, and that doesn't matter what value it is. All it's telling us that it's positive, right? So we know it's positive here. Taking 0, for instance, will give us negative 4 times 3. Well, that's negative. And then you have negative, take negative 4. That's negative 8 times negative 1, and that's positive. So we see this is positive, negative, positive. And now looking at this, we can, because we were supposed to find possible solutions for which this is greater than 0, we are looking at the positive values, right? And there is no equal, so we're only looking at it greater than 0. We don't care about the exact value of the critical numbers, right? We're looking at values greater than 4 or less than negative 3, right? If this was something like this, then we would also be including negative 3 and 4. Right, but in this case we're not. So our final answer would be the solution set includes x is less than negative 3 or x is greater than 4. So that's how you solve those types of problems. So that was question number 18. And again, using that concept of critical numbers, you can evaluate those inequalities, right, and determine their solution sets. So now we have question number 19 here. And so this one's x minus 2 squared times x plus 1 cubed times x minus 5 is less than or equal to 0. So we have this now. And so now we want to determine the critical numbers here. So just looking at the critical numbers here, we want to set each factor to 0, right? And we know the critical numbers. So the critical numbers here are 2, negative 1, and 5. Right? Setting each factor to 0, we get these critical numbers over here. And so now we want to again make our number line. And so just plotting this quickly here. So we have negative 1, we have 2 here, and we have 5 probably somewhere here. Right? And now we want to again take one value in these 4 intervals, right? 1 interval, 2nd interval, 3rd interval, 4th interval. So we take something like 6, right? Obviously 6 minus, this is positive, this is positive, this is positive, therefore this is positive. Take something like 3, right? You see that this is a positive, this is positive, however this is negative, overall must be negative. And then we have, we could take something like 0 here. So, doing this 0 plus 1 to the power of 3, we know that's positive. Negative 2 squared, that would be positive as well. And then 0 minus 5, that would be negative. So this one would actually be negative. So you see that it doesn't necessarily have to be that alternating sequence of positive, negative. You could all have something like positive, then negative, then negative. We take something like negative 2. Well, that here gives us positive, right? So we get a positive value here. Here we would get we would get a negative value in here, we would get a negative value, so these are positive times positive, that's positive, so we get a positive value here. And so we now we're looking at overall the solution set that is either equal to or less than 0. So we're looking at the negative values, right? And so now when we're talking about our solution set over here, our solution set would be something like this. Right? And if this makes sense, it's saying that x is greater than or equal to -1, or it's less than or equal to 5. And that makes sense because we are saying that it can be equal to 0. And clearly at the points -1 and at points -1 and 5, it is equal to 0, right? Because you plug 5 and you get 0. You plug -1 here, you get 0. So those points are included, and then you're looking at all points in between -1 and 5, because you have a negative, you're getting a negative value overall for values in between -1 and 5. So that's question number 19, right? And again, that's having to do with critical numbers. So I have another quick problem here with critical numbers. So again, here we are looking at question number 20 now. So question number 20, right? We have something like 3x minus 2 all divided by x plus 4 is less than or equal to 0. And this is a good problem because it indicates that to find critical numbers, we're not only talking about about certain factors and setting them to 0. We're really looking at all types of factors, whether those factors are in the numerator or in the denominator, and we're factoring them out and then setting each factor to 0 to determine the possible critical numbers. Now, if x plus 4 is set to 0 and we say that x is equal to -4 is a critical number, well, x is equal to -4 is still considered a critical number, although your overall value here is undefined. So you want to understand that concept that your critical numbers are determined by factoring out, by deriving those factors in the numerator as well as in the denominator. So there's no hard and fast rule that it has to be from the numerator. You're really just determining your factors and then setting them to 0 to determine your x values, which are your critical numbers. So here we can do that, and so we see that our critical numbers, right? Our critical numbers here are 2 thirds, right? That would be 1, and then the other one is -4. All I did is I set this to 0 and this to 0. So these are our two critical numbers. Then we make our number line. So we have -4 here. We have 2 thirds somewhere here. We take any value, right? Take 1. This here you get 1 divided by 5. So obviously this is positive. Take 0, right? So you get -2 divided by 4. That's negative. Take -5. Well, that gives you negative here, and that gives you negative here. So that's positive. So this is what we have here. And now we're looking at values for which this is less than, right? Less than or equal to 0. So if we're talking about less than, we are looking at a negative value, right? Or equal to 0. Now, when we write this, many people make the mistake of saying that it's equal to -4. Getting the -4 was just helpful for us to determine the critical numbers, and in reference make those, determine where we have our positive values, where we have our negative values. It just made it easier for us to do that. But when we talk about our solution set, that is -4 is less than, right? Is less than x, which is obviously less than or equal to 2 thirds. So this is our solution set. And it makes sense because we're talking about all possible x values for which you have the negative value here, because it has to be less than 0. So that would include, that would be your overall domain over here, right? So that's what it consists of. That's your solution set, but it is equal to 2 thirds, because putting 2 thirds into this equation, you do get 0. However, it does not include -4, because if you do put -4 into the equation, you get undefined. So that's your solution set over here. So that's question number 20. I do have one more problem dealing with critical numbers, but for this lesson, for this video over here, that is it. So thanks for watching.